Ladies and gentlemen, it is a great honor and pleasure for me to have the opportunity to talk to you today, and it's in a very impressive environment which we have here, and I thank everybody very much to be here and to share some thoughts with you about strategic security considerations and the importance of defense technology and civil security research in our nation's security and defense. Next view file, please. Looking around, I think it's a matter of fact that nearly all nations are facing the same strategic global security challenges. We are well aware that the strategic framework has changed significantly and has an impact on our current and future security environment in which national R&D efforts are conducted. Next view file, please. An expanding and increasingly integrated global economy combined with an accelerated technological evolution is affecting and will affect the forces of globalization over the next decades. This trend both enables and is enabled by the flows of energy, resource scarcity, money, people, technology, and information without regard to international borders. Next view file. Furthermore, the accelerating technological development and the availability of state-of-the-art means and devices for asymmetric warfare and terrorism are enhancing the capabilities of potential state and non-state adversaries considerably. The flow of weapons technology, materials, and knowledge is under the increasing danger of getting out of the control of international community and individual states. For sure is that the availability and the use of high technology by us and our potential opponents is a key characteristic of all future conflicts, military and civilian. Our R&D efforts should have this always in mind. Next view file, please. Technological innovation is strongly characterized by the need to develop strategies for managing the uncertainty in technology foresight in the future. Although technology forecasting by systematically looking into the long-term future of science and technology seems to be basically impossible, we need to perform mid-term or long-term forecasting of all disruptive innovations. Technology forecast in this context is understood as means for formulating a problem, obtaining information about it, and using forecasts. It covers all evolutionary aspects of technological innovation. As a rule of thumb, we know that it takes a few days to adapt tactics and fighting schemes, a few weeks or months to restructure forces, a few months or years to modify or mass-produce advanced armaments, and unfortunately, often more than 10 years to develop, apply, and to control a new technology. And I think General Chiarelli has mentioned that very clearly to us that is the real challenge for all of us here in the room and between all the nations we see. The question is how to adapt our R&D strategies to these changes where cycles of innovation getting shorter and shorter. But there are also more general issues we have to deal with. Next chart, please. One of these is a demographic change in our Western societies, which will have a massive impact on the employment situation in the armed forces, as well as in the civilian Bundeswehr administration over the coming years. I'm speaking now especially for Germany. In our armament directorate, for instance, we have already a significant lack of about 800 qualified scientists and engineers. Prospects are not very promising. As statistics show, this gap between demand of personal resources and available engineers will increase in the near future. This could also have an influence on personnel resources that organize and conduct our R&D work. In some of our technology areas, R&D work is already assigned as a secondary appointment ancillary to current project work. Besides recruitment, demographic changes are also playing a major role in connection with the planning of future equipments and systems for the armed forces. For example, If the physical and cognitive performance of younger peer groups decreases permanently, and low-achieving personnel must be employed to cover the authorized number of employees, this fact may have consequences for the technical equipment. On the other hand, rapid technological progress has effects on the management of personnel and training, as future systems and scenarios of deployment significantly determine the numerical and cognitive personnel requirements. The demographic change therefore forms a multi-layer and complex problem, which we have to cope with and where we need to offer technical solutions. Next slide, please. Furthermore, the obvious cutback of funds will influence governmental security precautions. Due to the package of measures our governments have taken to limit government expenditures over the next few years, we are expecting implications in many areas in our societies and therefore also to security and defense. Ladies and gentlemen, let me summarize. We are looking forward to a really challenging future regarding our defense and defense R&D. And it is a great challenge to keep our high demands to assure the national assessment and advisory capability for future military equipment across all relevant technology areas. But what needs to be done now? How will we cope with the problems? Next slide. Let me start with R&D. In the German system, we define 3 stages of R&D, which are distinguished by time, purpose pursuit, and closeness to tangible military applications. Together, they form a continuous spectrum of successive work steps, which in a consistent manner lead from the examination of engineering and science phenomena to the development of products that can be used by the military. Step 1, the research or the basic technology stage, which relates to TRL 1 and 2 in the international system, will cover work performed by the governmental research establishment or research institutes from the Fraunhofer Society and the German Aerospace Center, DLR. And let me mention here that we have in the exhibition hall a booth from the Fraunhofer Society, the group of defense and security research, which is, I think, a good chance to get a little bit more close into the work of the Fraunhofer Society, which is our governmental resource, I would say, for basic research in Germany. Step 2, future technologies, relates to TRL 3 and 4 and is mainly performed under the management of our governmental technical centers and industry. And step 3, system technology, relates to TRL 5 and 6 respectively. This step covers activities regarding risk reduction and system analysis studies for future equipment in preparation of a technical demonstration phase. Next slide. For Germany, I have to underline that defense research and technology activities of the respective research institutions and industry are, wherever possible, conducted by using relevant results from the civilian sector research as a starting point, mainly looking in those technologies which support civilian security and military defense research. That is the add-on principle. We call that add-on principle. We don't do basic research in a very, very broad manner. This is done by the government, by the Ministry of Science and Education for all the ministries in the German government. This modern approach to both security and defense technology includes synergies gained from the civilian security research used in defense research. Besides that, the national science community and the defense industry invest great efforts into their own research and development activities. In accordance with the add-on principle, respective R&D activities must be subject to early and reciprocal harmonization on a strategic level. Next. For the Bundeswehr, as one element of our national security precautions, There are many areas of interest that correlate with similar topics of the civilian security research sector, and we call that dual-use aspects. A joint effort of civilian security and military defense resources is a logical consequence which leads to a wider use of civil research results and products. Another important point is to introduce the end user's perspective into research. Scenario-based research enables the cooperation between researchers, governmental authorities, and industry. Furthermore, the cooperation between public and private infrastructure operators is appropriately ensured only with a scenario-based research approach. This approach supports also the exchange of knowledge between the civil and the defense sector on a common base. Next slide, please. To support the knowledge exchange between all relevant players, we have started to conduct workshops and symposia using a brainstorming approach. Experts from the defense-related and the civil research institutes, universities, military customers, and industries conducting research are invited on an annual workshop concerned with new technologies, future prospects in defense technology, in which technologies that are not included in the established planning on current projects are discussed in the form of a competition for ideas. Beside that, we have installed an R&T advisory council where the German R&T director, together with experts from the scientific research community, the military services, and the defense industry, discusses on a regular basis areas of highest interest for R&T, shortfalls in capabilities, and areas of priority with regard to future military systems. This will lead us to a more effective spending of R&T expenditures.